Welcome to aminacademy.com. In strength of material regarding thermal stresses in composite bars, let us do some solving problem. Example, a steel rod of 20 mm diameter passes through a copper tube of 50 mm external diameter and 40 mm internal diameter. The tube is closed at each end by a rigid plate of negligible thickness. The nuts are tightened lightly home on the projecting parts of the rod. If the temperature of the assembly is raised by 60 degrees Celsius, calculate the stresses developed in a copper and steel. Take E for steel and copper are 200 giganewton per meter squared and 100 giganewton per meter squared, and alpha for steel and copper are as 12 into 10 power minus 6 per degree centigrade and 18 into 10 power minus 6 per degree centigrade. Let us start the problem. Dia of steel rod now we'll do this way. Here we'll write steel, here copper. Dia of steel is 20 mm. Area is equal pi by 4, 20 square equal 100 pi. Here area of copper AC equal pi by 4, external 50, internal is 40, which gives 225 pi mm square. Now general rise in temperature (60 degrees centigrade). For steel ES, steel for ES equal 200 giganewton per meter square, which is equal 200 giga means 10th power of 9 Newton per meter square, which is equal 200 into 10 to the power of divided by 10 power 6 is 10 to the power of 3 Newton per mm square. Here for EC, E for copper is 100 giganewton per mm square, which is equal 100 into 10 to the power of 9 Newton per meter square, which is equal 100 into 10 to the power of 3 Newton per mm square. Alpha for steel, coefficient of linear expansion is 12 into 10 to the power of minus 6 mm per degree centigrade. And for copper, alpha copper is 18 into 10 to the power of minus 6 mm per degree centigrade. As alpha for copper is more, that is linear expansion of the copper is more than that of steel, hence the free expansion of copper will be more than that of the steel. When there is a rise in temperature, but the ends of the rod and the tube is fixed to the rigid plate and the nuts are tightened on the projecting parts of the rod. Hence the two members are not free to expand because it's tightened upside both sides. Then hence the tube and the rod will expand by the same amount because it's tightened. The plates ends the ends of the rods are tightened with the plates. The free expansion of the copper tube will be more than the common expansion. Common means together expansion, whereas the free expansion of the steel rod will be less than the common expansion. Hence, the copper tube will be subjected to compressive stress and steel rod will be subjected to tensile stresses. Now, further, for tensile stress tensile stress tensile stress in steel, this is let sigma C is tensile stress in copper. Then sigma S equal sigma, then you can say sigma S into area S equal sigma C into area copper. Therefore, sigma S you can write area of copper, area of steel into sigma C. So here 225 pi over 100 by we had done before, that is area of copper and steel, got it. Then which is equal 2.25 sigma C, sigma S equal we know that the copper tube and steel rod will actually expand by the same amount because it's tightened upside. Actual expansion of steel is equal to actual expansion of the copper. Actual expansion of steel equal actual expansion of copper. So which is equal here for steel side, free expansion of steel plus expansion due to tensile stress in steel, that is here alpha S temperature rise length plus sigma S over ES into L. This side is for copper alpha C into temperature into L minus contraction is the copper sigma for copper AC and L. So both equating because take L common out and cut, then we can equate like alpha S T plus sigma S ES here equal alpha C T minus sigma C EC that L will cut both sides. Now we'll apply the values. Now 12 into 10 power minus 6 into 60 plus 2.25 over 200 into 10 power 3 for E. Here the side is 18 into 10 power minus 6 into 60 degree change minus sigma C by 100 into 10 power 3. Now we'll collecting common terms one side, that is 2.25 by 200 into 10 power 3 plus here sigma C plus sigma C over 100 into here, because we have the ratio of sigma C and this relation sigma S equal 2.25 sigma C, therefore we are using here, and with 100 into 10 power 3 equal 18 into 10 power minus 6 into 60 minus 12 into 10 power minus 6 into 60. So here 2.25 over 200 into 10 to the power of 3 is 1.125 into 10 to the power of minus 5 sigma C. Here sigma C, here also we have 10 to the power of minus 5 sigma C equal 18 into here this side we have 36 into 10 to the power of minus 5. Now everywhere 10 to the power of minus 5, that is cut 1.125 sigma C plus 1, that is sigma C equal 36, which is equal 2.125 sigma C equal 36, therefore sigma C equal 36 over 2.125 16.941 Newton per mm square, and sigma is equal 2.25 times 16.941 equal 38.117 Newton per mm square. We have done. Please subscribe our YouTube channel.